Yeah, good evening. See, how many people completed assignment? Just raise your hands. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 members offline. Offline, online 5 members. So total 15 members only completed. Yesterday also same 15 members only. No? Today also 15 only same. At least how many you completed? 7, 5, 8, 5, 5, 5. How many you completed? Remaining people? I think not yet tried. You didn't try also. At least how many programs you completed? Just respond. 4 programs, 3 programs, 5 programs, 4. Online students, okay. Now see, the assignment, first assignment. This is only first assignment, no? No. This is first assignment, okay. See, first program, write a program to display. Listen with more concentration. Listen with more concentration, because at least the second assignment you have to do. Okay, at least second assignment. Okay. Now, write a program to display factors of a given number. See. But how to accept data dynamically? Till I didn't explain. Like a scanf function in C language. Okay. How to accept data dynamically? That is, I didn't explain, because if you want to use like a scanf function in Java, object-oriented programming knowledge required. That means scanner class, system.in.read, these all knowledge required. That's what directly in the program only I'll write the value. Okay, dynamically later. See, dynamically if I write, you'll get a confusion also. I'll show you dynamically also on program. I'll show you. Observe. File, open, something demo. See. See here. Write a program to display factors of a given number. Write a program to display factors of a given number. Any one number you have to take. For example, integer a equal to 15. Integer a equal to 15. Okay, any one number randomly you take. Now, but dynamically if you want to enter, I'll show you. That is also I'll show you. Now, integer a equal to 15. Now, after this, see, write a program to display factors of a given number. One number is 15. 15 factors. 15 factors. What are the factors? 1 is a factor, 3 is a factor, 5 is a factor, 15 is a factor. 1 to 15 only will be there, no? So one range is there. Range is there means we have to write loop. So starting 1, ending given number. Ending given number. So starting is 1, ending is 15 is there, 15. 20 is there, 20. 40 is there, 40. 200 is there, 200. Whatever is there. Okay. So we have to write one loop. We have to write one loop. Either while loop or do while or for. But what's the difference while, do while, for loop you studied, syntaxes you studied. But when we have to use while, when we have to use do while, when we have to use for loop. For this type of programming, no difference. Any loop we can use. Object-oriented programming, different comes. That is, you will understand later. When we have to use for loop, when we have to use while loop, when we have to use do while. So actually, if you know the number of iterations for loop, if you don't know number of iteration while loop, at least the body should execute one time means do while. Like that we'll select. That is, in object-oriented programming, difference comes. But here while also, do while also, for also same appears in this situation. Now, see, factors will be 1 to 15. If 15 is there, 15. 20 is there, 20. Like that. So, for loop, integer I equal to 1, I less than or equal to A. A value 15 is there, 15. A value 40 is there, 40. A value 300 is there, 300. I plus plus. Like this, one loop you have to write. Okay. Now, given number is 15. 1 to given number loop. Now, we are calling 1 is a factor, 3 is a factor, 5 is a factor, 15 is a factor. But how do you know that is factor? Division operation. Division operation, if remainder 0. If remainder 0 comes, that is called factor. Remainder 0 required. Remainder means which operator required? Modulo division operator. So, condition. If it is remainder 0, if now A, modulo division I, you will get a reminder. That reminder, if it is equal to 0, that is called factor. Then system dot out dot println I. Over. That is first program. So what it will do here, A value 15. First I value 1. 1 less than or equal to 15, true. A 15 modulo division 1. You will get a 0. True. Then printed. It will become 2. 2 less than or equal to 5. 2 less than or equal to 15. True. 15 modulo division 2. 2 7 ja 14. Remainder 1. 1 double equal to 0. False. It will not print. Then I becomes 3. 3 less than or equal to 15. True. Then 15 modulo division 3. 3 5 ja 15. So remainder 0. So it is true. Then it is printed. If remainder 0 comes, printed. Remainder any other comes, it will not print. Okay. For example, you observe. I'll show you tracing also. I'll show you. Suppose I'll take 6. I'll take 6. Okay. Now you observe. Tracing also I'll show you. Listen with more concentration. First of all, int A equal to 6. A value. Don't write, first listen. Don't write, first listen. A value 6. Okay. Int A equal to 6. A value 6. After this, int I equal to 1. Because this is executed, no? First this is executed. I value 1. I value 1. After this, I less than or equal to A. That means 1 less than or equal to 6. 1 less than or equal to 6. Is it true or false? True. It will enter. True means it will enter. Okay. True means it will enter. Now this condition will check. Now 6 modulo division 1. 6 modulo division 1. That means 1 6 ja 6. 1 6 ja 6. Reminder 0. Reminder 0. That means 0 double equal to 0. True. This is 0. So 0. 0 double equal to 0. True. System dot out dot println I. I value printed. So output 1. 1 printed. After printing 1, control comes to I plus plus. I plus plus. So this condition true. That is the reason printed. This condition true. That is the reason printed. After printing, I becomes 2. I becomes 2. From here, again control comes here. 2 less than or equal to 6. 2 less than or equal to 6. It is true. Okay. Then again, A modulo division I. Nothing but 6 modulo division 2. 2 3 ja 6. 2 3 ja 6. So again remainder is 0. It is also 0 double equal to 0. True. System dot out dot println I. What is I value? 2. 2 printed. After printing 2, I becomes 3. I will become 3. 3 less than or equal to 6. 3 less than or equal to 6. It is true. It will enter. Okay. Now 6 modulo division 3. See, other I can switch off otherwise. 3 2 just 6. 3 2 just 6. Remainder 0. 3 2 just 6. Remainder 0. So 0 double equal to 0. True. System dot out dot println I. 3 printed. After printing 3, it will become 4. Okay. 4 less than or equal to 6. 4 less than or equal to 6. Okay. It is true. Then 6 modulo division 4. 4 1 ja 4. Remainder 2. So you will get it 2 here. Now 2 double equal to 0. False. Here 2 double equal to 0. False. Then out of if. Out of if. Okay. Out of if. But after this, again I plus plus comes no. I plus plus again. So here if it is false also, it will comes to I plus plus again. Out of if, after that I plus plus. I will become 5. I will become 5. Now next 5 less than or equal to 6. It is also true. 5 less than or equal to 6. It is also true. Then 5 1 ja 5. Remainder 1. Remainder 1. 1 double equal to 0. False. 1 double equal to 0. False. False means it won't print. It will not print. So out of if. After this, I becomes 6. I will become 6. 6 less than or equal to 6. It is true. Okay. It is true. Then 6 modulo division 6. 6 modulo division 6. 6 1 ja 6. Remainder 0. Remainder 0. 0 double equal to 0. True. Then system dot out dot println. 6 printed. After printing 6, I will become 7. Just turn off it. Uh, 7 less than or equal to 6. 7 less than or equal to 6. False. False means out of for loop. So out of for loop. Now out of for. It is stopped. Okay. So what is output? 1, 2, 3, 6. Now it is not this logic not only for 6. Any number. Any number. Just in the place of 6, whichever number you write, that number of factors comes. Okay. Write this one. This is first program. This is first program. Note down. So 1 is a factor, 2 is a factor, 3 is a factor, 6 is a factor. 1, 2, 3, 6 is the output. So program to display factors of a given number. Program to display factors of a given number. Program to display factors of a given number. Is it over? Are you writing or discussing? Again discussion only. Every day. Or I think up to last class we'll discuss like this only. Is it over? See, first A value 6. 1 to 6. That loop. 1 to 6. If A value 15. 1 to 15. Loop. If the remainder is 0, printing. That is only factor. That is only factor. See, file, save. If I compile. See, if I compile and execute. Java C demo.java. Java demo. See, 1, 2, 3, 6. Suppose here 15 if I write. File, save. 15 factors comes. Program remaining same. See, 1, 3, 5, 15. Suppose 415 if you write. 415 factors also comes. File, save. See, 1, 5, 83, 415. Suppose 4156. See, now any number, logic is same. See, all factors comes. Okay, so factors will be displayed like this. Now, here if you want to accept dynamically, actually in Java, we have to write like this. Scanner s equal to, this is, you cannot understand, that is the reason later I'll give. If you want, I'll show you. Scanner s equal to new scanner. Scanner is on class. That class object we have to create first. That class available in util package. Java.util.star. So scanner is a one predefined class. That class object we have to create. While creating system.in we have to pass. So this in is a input stream reference. It is present in system class. It is static variable. With class name you have to pass. After this you can accept system.out.print. Print means same line. Enter any number. Now this a equal to s dot next int. One method is there for getting integer. If you write like this, you will get a number dynamically. See, file, save. Now compilation, execution. See, enter any number 8 factors. Again, enter any number 98 factors. Enter any number 76 factors. Enter any number. See, whatever you want, you can enter. Okay. Now dynamically like this. Now anything you can enter. But this code you may not understand today. That's the reason I given like that. This is dynamic code. Okay. If you want, write this program also, one program. So these 2 lines after that year, if you write dynamically, otherwise you can write number, year, present, you follow. Later you will understand this. So enter any number displayed on monitor. Whatever you enter, that is stored in A. But this method, if you want to call, scanner class object required. Scanner class object you have to create that reference. With that reference I called. But this scanner class takes input stream. For receiving data from keyboard, input stream required. That input stream is a reference variable. It is in system class. It is static. That is the reason with class name you have to write. If you understood also okay. If you don't understand also, no need to worry. Later you will understand. After completion of object oriented programming, you will understand. Okay. Then very depth you will understand. Because object oriented programming not completed, just started. That's what you may or may not understand this one. Now, this is first program. Dynamically, if you want, only this code attach for every program. Dynamically, if you want. Okay. Now, second program. What is second program? See, write a program to display sum of the factors of a given number. That means first program extension only. Suppose this is I'll remove, present I'll write only, suppose here 6 I'll write. Now this is you have seen 6 factors displayed. 1, 2, 3, 6. But what you have to do, we should not display factor now. We have to add. That's what one variable, integer, something total equal to 0. For this total, you add total equal to total plus I over. After termination of for loop, system dot out dot println total. If it is factor, add it to total. If it is factor, add it to total. Now this util package not required, scanner class purpose I given. See, here what will happen? A value 6, total 0. A value 6, total 0. Now I value 1. I value 1. Now 1 less than or equal to 6. Now 1 less than or equal to 6, it is true. 1 less than or equal to 6, it is true. Then here 6 modulo division 1 double equal to 0. That is true or false? True. 6 modulo division 1 double equal to 0. It is true or false? True. Just now you have seen. It is a factor. If it is factor, total equal to total plus I. What is total? 0. What is I? 1. 0 plus 1? 1. 1 is stored in total. It will become 1. It will become 1. After this, I plus plus. I will become 2. I will become 2. 2 less than or equal to 6. True or false? True. It is true. Okay. Then 6 modulo division 2. 0. Double equal to 0. True or false? True. If it is true, what will happen? Total equal to total plus I. What is total? 1. What is I? 2. 1 plus 2? 3. It will become 3. Like this only, again I plus plus. I will become 3. After 3, I less than or equal to A. 3 less than or equal to 6. Okay, 3 less than or equal to 6. True. Then it will enter 6 modulo division 3. 6 modulo division 3, 0. 0 double equal to 0, true. So it is also 0. It is true. Then total equal to total plus I. What is total? 3. What is I? 3. 3 plus 3, 6. It is 6. Later I becomes 4. I will become 4. 4 less than or equal to 6. 3. 4 less than or equal to 6, true. Okay. Now true. Then what will happen? 6 modulo division 4. 6 modulo division 4. Reminder, 4 1 is 4. Reminder, 2. 2 double equal to 0. False. False means it is not added. Now out of if, I plus plus, I will become 5. I will become 5. 5 less than or equal to 6. True. It is true. But 6 modulo division 5. 6 modulo division 5. 5 1 is 5. Reminder, 1. 1 double equal to 0. False. It is also not added. I will become 6. 6 less than or equal to 6. True. 6 less than or equal to 6. It is true. Then 6 modulo division 6. 6 modulo division 6 is 0. 0 double equal to 0. True. Then 6 plus 6. 12. 12. Then out of for loop, out of 7, it will become 7. It will become 7. 7 less than or equal to 6. False. Then out of for loop. Out of for loop, what is there? System dot out dot println total. What is total? 12. This 12 is the output. So previous program, this program, only one difference. In previous program we displayed. This program we are adding to total. After completion of for loop we are printing total. That is only difference. Got it? Write this one. Program to display sum of the factors of a given number. Second program like. So in other batches, strength is very less today, but your batch is very good. Good strength. Online also, offline also. That means all are interested students only. Very good. But like this only continue up to last class. So sum of the factors displayed. So previously if condition here printed, but here adding to total. We are adding to total. So first program, this program only difference here we are adding to total. That's it. That is printing here, printing total only. We are calculating. Is it over? If the condition is true, it will be added to total. Okay. This is second program. Now third program I'll show you. See, third program. Third program. Write a program to check whether given number is perfect number or not. Suppose 6. You studied 6 factors. 6 factors you studied. What are the 6 factors? 1 is a factor, 2 is a factor, 3 is a factor, 6 is a factor. Okay. 1 is a factor, 2 is a factor, 3 is a factor, 6 is a factor. Okay. Except 6. Except 6. This is except 6. These 3 if you add 1 plus 2 plus 3. What is the result comes? 6. So if it is equal to given number, that is called perfect number. So except 6 means what you have to do here? I less than or equal to is there. What we have to do? I less than A. If I remove that, except 6 remaining calculated, you will get a total. Here after getting total, if total equal to A, system dot out dot println perfect number. Okay. So given number is perfect number. Like that again write if you want. Given number is perfect number. Given number is perfect number. Else given number is not a perfect number. Like this you can write. See, file, save. If I compile and run, see, given number is perfect number. Suppose 14. 14 factors. 1, 2, next 7. 14 we should not include. 1 to 7. 1 plus 2, 3. 3 plus 7. Is it perfect number? No. Compilation Java demo. Given number is not a perfect number. Okay. Suppose 28. 28 factors. 1, 2, next 4, next 7, next 14, next 28, except 28. So 1 plus 2, 3, 3 plus 4, 7, 7 plus 7, 14 plus 14, perfect number, no? See, perfect number. Compilation, execution. See, given number is perfect number. Okay, write this one. Program to check whether given number is perfect number or not. Third program. Program to check whether given number is perfect number or not. Program to check whether given number is perfect number or not. So first program extension is second program. Second program extension is third program. So program to program little bit different, you observe. Like that only you'll get a logical skills. Now, next program again little bit different. Next program also perfect numbers only. Is it over? See. Next program, write a program to display all perfect number between 1 and 1000. Same logic we have to write inside one loop. 1 to 1000, one loop you have to write. One number we have to check whether it is perfect or not. If it is perfect, we have to print. So, one for loop you have to write. For loop, this a place only 1 to 1000. So, for integer a equal to 1, a less than or equal to 1000, a plus plus. This is for loop open, here for loop close. Now this is just only a place what I did, I written one loop. But here what we have to do, if it is perfect number, we have to print that number. That is the reason system.out.println, what you have to write? A. This else is not required. Over. Now what it will do, first one number it will take, that is perfect or not it will check. If it is perfect, print it. Again second number it will take, a plus plus, that it will check, that will print. So 1 to 1000, what are the perfect numbers are there, all will be printed. See, this is only fourth program. See, Only 3 perfect numbers are there. 1 to 1000. Only 3 perfect number. 6, 28, 496. Okay. So each and every number, whether it is perfect or not, it will check. The loop 1000 times iterated. 1000 times iterated. Again each number, that many number of times, whatever number values comes, that many times iterated. See, very quickly response. Fraction of seconds, how many times program executed, you observe? So 1000 numbers, one number checked. Write this one. Program to display all perfect numbers between 1 and 1000. Program to display all perfect numbers from 1 and 1000, between 1 and 1000. This is fourth program. Okay. Is it over? Now, fifth program, you observe. Write a program to display all perfect numbers in a given interval. Instead of 1 to 1000, you can select the interval. That means dynamically you have to accept actually. Dynamically means present not possible. That is scanner class you have to use. Enter starting number, enter ending number. Whatever number comes, you can pass. Like that you can write. Okay. Otherwise, here only change. Suppose scanner class means again scanner s equal to new scanner. Here system.in. Okay. System.out.print. Out.print. Enter starting number. Now store in one variable, integer x. Yes dot next int. Again system.out.print. Enter ending number. Integer y. Yes dot next int. Where we have to write x and y? Where we have to write x and y? A equal to x. 1000 equal to y. File. Save. See. Scanner class available in util package. We have to import. Import java.util.star. File. Save. See. Compilation. Execution. Enter starting number. Suppose 5000. Enter ending number. Suppose 50,000. Now between 5000 and 50,000, what are the perfect numbers are there? Those numbers displayed. it is taking time because one number it has to check up to 50,000. Only one number is there. Between whether it is right or wrong, if you want to confirm, like again 1,000 you can write, no, previously whatever we got, that result comes. I didn't change logic also, I didn't change program also, only starting number ending number added. Okay, so see, after 496 next number is 8,128. In between numbers are not there, perfect numbers are not there. See, if you write 1 lakh, see 1 lakh, up to 1 lakh it is checking, still it is checking because crores of times iterated, that is. Now it is not only 1 lakh iterations, not only 1 lakh iteration, each number again up to that number iterations required. So crores of times iterations, that's what it is, it has taken time. So 1 to 1 lakh only 4 perfect numbers are there, you observe. Okay, like this, starting ending, write this one, given interval, program to display perfect numbers in a given interval. Program to display perfect numbers in a given interval. Otherwise you can write 1 2 3 4 1 numbers, later you can see the assignment, you can write it. The fifth program in assignment, fifth program. Program to display all perfect numbers in a given interval. So whatever you enter, that is going to be stored in Y. That's what. Otherwise, the scanner class I'll teach later. Is it over? Is it over? Not over? See, scanner class object created. Scanner class object created here. Scanner is on predefined class. Predefined class. Like a string class, system class, one scanner class. Scanner class object created with input stream. Because accepting data from keyboard means this is compulsory required. What is this? You'll understand further sessions. Okay. Enter any number displayed on monitor. Whatever you enter, that is stored in X. Enter any ending number displayed on monitor. Whatever you enter, displayed in Y, stored in Y. Okay, like X to Y range. In that, perfect numbers printed. This is fifth program. Next one, sixth one. Write a program to check whether given number is prime number or not. See, suppose it is also factor related only. Suppose 7 is there. Now 7 factors, 1 and 7. 1 is a factor, 7 is a factor. Okay, no other factors. Suppose 9 factors, 1, 3, 9. So 1, 3, 9. Now suppose 31 factors, 1, 31. No other factors. Okay. Now, if only 2 factors are there, only 2 factors, that is prime. Here, prime. More than 2 is there, not a prime. Now, what we have to do, we have to count the factors. We have to count the factors, not adding. Then what you can do, previous program only, you observe. Previous program only, same program, you observe. I'll remove this. Okay, here, int a equal to, suppose 7. Okay, now, here 1, 2. This loop not required, no? Okay, 1 minute. This loop also not required. This is also not required. Now see, here, int a equal to 7. Int a equal to 7. Now, here factors are added. Factors are added. Now, adding not required. I less than or equal to a. Now, just counting. Suppose count variable. Count I want to increment. Count plus plus. Now, if it is factor, count will increase. If it is factor, count will increase. Now, a value 7. A value 7. Count equal to 0. I value 0. 0 I value 1. 1 less than or equal to 7. True. And here true. Count will increase. 1. Otherwise trace. I'll trace. Here. If count double equal to 2, system dot out dot println given number is prime number. Okay. Else system dot out dot println given number is not a prime number. This is one logic. One more logic also possible. Now see here. Now this is not required. I'll remove. See, I'll trace. With the tracing, you'll get a more clarity. See, a value 7. Listen with more concentration. Int a equal to 7. A value 7. Int count equal to 0. So count value 0. int I equal to 1, I value 1. Okay. Now 1 less than or equal to 7. I'll give time for writing. Listen. 1 less than or equal to 7. It is true. Okay. Say once again, a value 7, count value 0, I value 1, 1 less than or equal to 7. It is true. It will enter. Now 7 modulo division 1. What will get it? 0. 0 double equal to 0. True. Then what will happen? Count will increase. Count will become 1. After this, I plus plus, I value 2. I value 2. Again, 2 less than or equal to 7. It is true. Then 7 modulo division 2. 2 3 is 6. Remainder 1. 1 double equal to 0. False. It will not increase. It is out of if. Out of if, after that I plus plus. So I will become 3. I will become 2. Sorry. This is count. Now I will become 3. 3 less than or equal to 7. 3 less than or equal to 7. It is true. 7 modulo division 3. 3 2 is 6. Remainder 1. 1 double equal to 0. False. So count will not increase. I will become 4. 4. 4 less than or equal to 7. It is true. It is true. 7 modulo division 4. 4 1 is 4. Remainder 3. 3 double equal to 0. False. I plus plus 5. I will plus plus 5. 5 less than or equal to 7. It is true. It is true. 7 modulo division 5. 5 1 is 5. Remainder 2. 2 double equal to 0. False. It will become 6. 6 less than or equal to 7. It is true. Then 7 modulo division 6. 6 1 is 6. Remainder 1. 1 double equal to 0. False. So it will become 7. 7 less than or equal to 7. It is true. 7 modulo division 7. 0. 0 double equal to 0. True. Then what will happen? Count will become 2. Now I becomes 8. I becomes 8. 8 less than or equal to 7. False. 8 less than or equal to 7. False. For loop terminated. Count to double equal to 2. What is there? 2. Then given number is prime number. While performing this operation for 6, count what it comes. Count value 4. Then count to double equal to 4. False. Given number is not a prime number. Like that it will check. Count suppose 15. Number is 15. What it count? 15. 4. Count to double equal to 4. False. Given number is not a prime number. Suppose 5. 2. Given number is prime number. This is one way. One more way I'll show you. Write this one. Program to check whether given number is prime number or not. Program to check whether given number is prime number or not. Program to check whether given number is prime number or not. Counting number of factors. counting number of factors. Okay, if factors are only 2 factors are there, prime number. More than 2 is there, not a prime. Is it over? So those who didn't do this assignment, just what you do is, at least without seeing the notebook, again you try. Okay, if you get a wrong output, you trace. Still you are getting wrong output, one more time you check. Still you are getting wrong output, then opens notebook, check what are the mistakes you did. But as it is int a equal to 7, int count equal to 0, don't do. That is called data entry. That is not called practicing. Okay, as it is, they'll open notebook, class demo, public, static, as it is, they'll type. Public is there, public, static is there, static, while is there, while, for is there, for. That is anyone can do. If you give this notebook to first class student also, he'll type as it is. Because for typing as it is, Java knowledge not required. English knowledge, typing knowledge required. Java not required, as it is typing. So, don't do data entry, you try to do it. Think logic, try to write. Still if you get a wrong output, one time trace, one time or 2 times. Still you are getting wrong output, then opens notebook, what are the mistakes you did, check it out. Okay. Next, see. This is prime number or not, we can check like this. One more way, suppose example, this number is 496, assume. How many times for loop iterated? How many times iterated? 496 times iterated. Okay. Now, suppose 496 is not a prime, because with 2 only it is possible. Then only you can stop, no? 1 and given number, only 2 factors are there, that is prime. Between 2 and given number minus 1, in between is there, you can stop, you can break the loop, it is better, no? So what you can do is, here instead of writing this one, this is 496 times iterated, 496 times iterated. After that count is not 2, then given number is not a prime number comes. But instead of this, see, suppose suppose 15, if the number is 15, how many times this for loop iterated? 15 times iterated. Now here 1 is a factor, 3 is a factor, 5 is a factor, 15 is a factor. Here whenever 1, 3, 5, 15, it is 15. Now 1, 3, 5, 15. Now 4 factors are there, so it is not a prime number. Now whenever 3 comes, then only can stop, no? Then only can stop, it is not a prime. So what we can do, except 1, except 15, you have to start with 2, end with 15 minus 1, 14. In between, if factor is there, you can stop, it is better, no? So what we have to do here, if a value, whatever it may be, a value, here you have to start with 2, given number minus 1, Otherwise less than. If factor is there, break. Factor is there, break. But what we can do, one variable you have to take. Now count not required. Suppose what I'll do, one boolean value I'll take. Boolean b equal to, suppose first I'll write true. If it is factor is there, that b value false I'll write. I'll break. Now here, you observe, if b, now here starting, I'll take suppose 7. I'll take 7. Now 7, a value 7. Okay. Boolean b equal to true. Now you observe, a value 7, b value true. Okay. Now I value 2. 2 less than 7, true or false? True. 7 modulo division 2 double equal to 0, false. If condition not executed, I plus plus, I will become 3. 3 less than 7, true. Here false. I plus plus 4. Here true. Here false. 5. Here true. Here false. 6. Here true. 6 less than 7, true. False. Here 7. 7 less than 7, false. Stop it. Then what is the p value? True. Here if true means given number is prime number. Suppose a value 6. A value 6. A value 6. B value true. B value true. Now I value 2. I value 2. 2 less than 6, true. It will enter. 6 modulo division 2, 0. 0 double equal to 0, true. Then what is the b value? It is false. False. After that what will happen? Break. It breaks the loop. If b, what is b? False means what will happen? Else block. Given number is not a prime. Now how many times iterated for this loop, this program now? One time only. One time only iterated. Suppose number is 496. How many times iterated? One time only. But previous program 496 times. It is better, no? You can break the loop. See? File. Save. You can compile. You can execute. Given number is not a prime number. With only one time only, stop it. Suppose if it is 7, see, file, save. See, given number is prime number. Working, no? This is one more way. This is better or that is better? This is better. Right, this one? What will write? Given number is not a prime. After that you can break. You can write. Now if it is false place, directly system.out.println given number is not a prime number and break. And after this, here what will write? After break, that is also printed, no? Now that is okay. First what will happen here? B equal to false place, system.out.println given number is not a prime number. Break. It will break. After break, what will happen here? Prime number it is. Else statement. Here else statement you are asking. Without break. Without break or with break? With break. Next, what you are write? Else again and again executed else. here after if write for every iteration else executed, no? Every iteration else is executed. Suppose else if I write, how many times else executed? Again and again executed. Many times executed. That's what, that is only right. Suppose if you write here system.out.println given number is not a prime, that is okay. After break also given number is prime also displayed. That means given number is not a prime number, again given number is prime number, both displayed. That problem comes. Okay. Write this one. Or how many programs completed? 6. 6 completed. It is also 6 one only. 6 one more logic. Okay. At least remaining programs can you try up to Monday? Okay. You try up to Monday, but tomorrow I'll teach methods. Methods continuation. Monday I'll discuss about this remaining 5. Remaining 5 programs I'll discuss on Monday. Okay. But tomorrow methods, yesterday methods not completed. Methods I'll continue tomorrow. Tomorrow we'll see continuation.